Lesson 37 is about inequalities and about using number lines to express solutions to inequality equations. Now, the best way to understand expressions with equalities and solutions to expressions with equalities is to use a number line, and that's what we'll be doing in this lesson. So I have a number line there on the board, and an equation that's real simple is x equals 2. Now, if I wanted to express that on a number line, that equation, the solution to that equation on the number line, I would just put a dot right there at 2. And that would express that equation, the solution to it, x equals 2. Now, if I had x greater than 2, the way I would express that, and I'm going to write this above the number line. Normally we would write on the number line, but I'll just go ahead and do it above it since I already have something there. X greater than 2, you would put an open circle there because it's not equal to 2. An open circle tells you that it's not equal to that amount. And then you would just shade in to the right because there's actually a solution set for that expression. There's not just one number involved like in x equals 2. There's only one answer to that. X greater than 2, that means all of the numbers greater than 2. So you put an open circle there to show that you're not counting 2, but like 2.0001 would count because it's just a little bit greater than 2, and that's what that expression is telling you. So likewise, if I had x less than 2, the way I would do that is another open circle at 2, but this time I would shade in to the left. And so that would express x less than 2. Now, what if I wanted to express x greater than or equal to 2? That's the symbol that we use. It kind of looks like an equal sign and a greater than sign together. What if I wanted to express x greater than or equal to 2? Well, what I would do there, and let's look at our x greater than 2 arrow that I have drawn there, our solution set in green. What we would do is just shade in the circle. And now that is an expression of x greater than or equal to 2, because the shaded in circle tells us we're including 2. And that's what we do. And when we say x greater than or equal to 2, we're talking about the set that includes 2 because it's equal to 2, and then greater than 2 as well. Now, the last one would be x less than or equal to 2. So look at our red solution set arrow that I have drawn there. And right now it's for x less than 2. To make it x less than or equal to 2, we shade in that circle. And now x less than or equal to 2, that's what that red line and circle express. We're including 2 and then everything less than 2 as well. So the blue dot, that's basically a graphical expression of the equality x equals 2. The green and the red arrows, those are solution sets. There's a whole set of numbers that are included in those inequalities. And that's where a number line comes in handy, is because we can express that visually, what the solution set looks like and what it includes. Let's do a practice problem. In A, I want you to graph the solution of that expression, x less than or equal to 4. So graphing it, what I mean is to use a number line. When you see that in a problem set, it says graph the solution to that inequality. They want you to use a number line. So let's go ahead and make a number line. And we'll need to make sure and include 4 on our number line somewhere. So I'll just go ahead and put a 4 in the middle here to make sure I've got it on there. And then I don't really need to put all the other numbers on there. It's not that important, but I'll go ahead and do it. Okay, now we want to graph the solution for x less than or equal to 4. So less than or equal to 4, that means we will include 4. And so I'll put a closed circle there at 4, and then it's less than or equal to 4. That's our solution set, so we'll shade in to the left. Now remember, in my example above this, I didn't do these arrows and the shading in. I didn't do that on the number line, but that was just because I already had something else on the number line. Normally that's how you'll do these problems. You just do your shading in and draw your symbol of inclusion, your circle, your open or closed circle there at that point of where it starts. Now if that problem would have said to graph the solution of x less than 4, we would have had an open circle at 4 because we would be expressing that we're not including 4 but just all numbers slightly less than 4 and on. Let's do one more problem. In this one I've already got a solution or a graphed solution for an inequality. What I want you to do is show me what that inequality is. Just write it down in the form with a less than or equal to symbol or whatever you need. So look at that and you see an open circle at -2 and then it's shaded to the right. So that means we're talking about greater than -2. That's the solution for that inequality, is numbers greater than -2. So we can just use x to represent the variable there because the number varies, right? It could be a -1, it could be a 0, it could be a 1.5. So we use a variable x greater than -2. So that would be the inequality represented by that expression. So make sure when you're doing these problems that you know the different types of inequalities, the different symbols and what they mean. Make sure you know the difference between an open circle and a closed circle when you're graphing an inequality as well. Okay, well that's all for lesson 37.